Hello everyone, this is Mr. Underkoffler. Today we're looking at the guide of notes called cross sections. So what is a cross section? Well, follow along with me here. A cross section is the two-dimensional shape, which means flat shape, that results from slicing a three-dimensional figure, a 3D figure. The shape of a cross section depends upon the shape of the solid figure, the angle that the plane or slice makes with the base of the solid figure, and it also depends on where the plane intersects the figure. Okay, here are some examples, and these are going to be cross sections of a cylinder. You can see the vertical slice makes a rectangle. The angled slice is going to make an oval. You could also call this an ellipse. And the horizontal slice is going to make a circle. Now you might be like, Mr. Underkoffler, this doesn't really look like a circle. It looks like an oval. And over here, this doesn't really look like a rectangle. It kind of looks like a parallelogram. Well, that's because you're looking at it not straight on. So let me show you what happens here when we actually look at these slices straight on. So right here, again, we have a cylinder. If I look at this circle straight on, hey look, it actually looks like a circle. Now, I can change the angle here of this slice. Right now, it's an angled slice instead of being parallel to the base. So if I have it angled, it stretches that circle, and you can see now this makes an oval, also known as an ellipse. And then if I really make this a totally different slice and make it perpendicular to the base, then you can see, if I look at this straight on, it is a rectangle. It's like looking at the side view of the cylinder. So that gives you a little bit more perspective here on how we are actually getting these names of these cross sections. Now, ladies and gentlemen, this box that I have here near the top right, you should put some stars around this. This box here is huge. This is very important. When a three-dimensional figure is sliced parallel to its base, the cross-section will be the same type of shape as the base, but not always the same size, depending on what the 3D figure is. So you guys should know a cylinder has a circle at the top and a circle at the bottom as its bases, the way that it's drawn here. Well, when I make that slice parallel to the base, then it makes the same type of shape as the base. Now, when it's perpendicular to the base, then that's a different ballgame. Then you kind of need to look at the side view of how a cylinder would look. Okay, at the bottom half of your page, we got some more examples here. These are cross sections of a cone. Here we have it parallel to the base, and it's going to make the same type of shape as the base, but not as big of a circle as what you see at the bottom. It's going to be a little bit smaller. If it's perpendicular to the base, then it's like a side view of that cone. And if it's an angled slice, then instead of being the same shape as the base, it's kind of stretched. That's going to be an oval, or you can see here we called it an ellipse. And here you're going to see these slices kind of in real time. If I make it parallel to the base and I look at this straight on, you can see it's a circle, but it's not as big of a circle as what you actually see on the base. If I angle it, then it stretches it, making look kind of like a circle, but a little bit more stretched. That is an oval or an ellipse. Now, if I really angle it, then it changes where it actually enters the 3D figure. You can see this is no longer a perfect oval. It's kind of like a half oval, somewhat. And then if I make it perpendicular to the base, and I look at this straight on, you can see, it's like a side view of the cone, which would be a triangle. So the angle of the slice definitely determines what type of cross-section you're going to get. Okay, let's turn to the next page. Pencils in your hand. We're going to draw a sketch and name the shape. So this is kind of two parts of the directions here. We're going to draw a quick little sketch, and we're going to name the shape resulting from each cross-section of the square pyramids that are shown below. Now, on my screen here, you can only see one of the pyramids and one of the slices, but you guys on your paper also have the vertical slice, perpendicular to the base, and the angled slice. So let's take a look at this. what type of shape is this? Well, you can see we have 4 sides. Now, right now, it kind of looks like a parallelogram or a rhombus, but if you would look at this straight on, here's what it would look like. It's the same type of shape as the base, but not necessarily the same size. The higher up the slice is, the smaller this would become. The lower the slice is, the bigger it would become, closer to the size of the base. Now, you might be like, well, what is that base? Is that a rectangle? Is that a square? Well, you might want to highlight this. I literally said that these were square pyramids, meaning the base is a square. So, if it's parallel to the base, then it's going to be the same type of shape as the base, which would be a square if our base is a square. So go ahead and draw that sketch and name it a square. Now, what about the vertical slice? Well, you can see it's definitely not a square. It has 3 sides. Think of a side view of a pyramid. If you looked at the Great Pyramids of Egypt from a side view, what would you see? You would see a triangle. So go ahead and quickly sketch that and name it the side view, the vertical slice perpendicular to the base if it goes through the vertex at the top. That's why I typed this up here. Going through the vertex at the top. If I move it over and it doesn't go through the vertex, then it would actually make a trapezoid. But here going through the vertex, we can see this is going to make a triangle. And finally, the angled slice. This was a little bit trickier. Angled slices are normally trickier. We have one side here, one side here, a third side here. Oops, sorry, I didn't quite draw those straight. And a fourth side here. Let's try to draw this looking at it straight on. Here's what you would have. Now, what is the name of that shape? This is a trapezoid. It's not the traditional drawing of a trapezoid. A traditional drawing of a trapezoid looks like that, but this is the way it looks like the way that we had it, but that is still a trapezoid. 4 sides, the left and right side are parallel, but the other 2 sides are not. That's what makes it a trapezoid. Okay, so I led you through some examples. They were all from square pyramids, but now you have 7 practice problems of different types of 3-dimensional shapes and different types of slices. Some of them are parallel to the base, some of them are perpendicular, some of them are angled, and some of them are just at different locations, as you will see at number 6, kind of an interesting way of slicing it. So I want you to go ahead and try these 7 problems, 2, 3, 4, 5, 6, 7, and 8. Hit pause now, try them on your own, and then hit play when you're ready to see how you did. Okay, did you already answer? Numbers 2, 3, 4, 5, 6, 7, and 8. If not, you better quickly finish them on your own. Hit pause, then hit play to see your answers. So we, number 2, have a horizontal slice parallel to the base. Well, the base is a rectangle, so this means this is also going to make a 1, 2, 3, 4 sided figure. It's going to be the same type of shape as the base, which would be a rectangle. There you go. Problem number 3. This one is not parallel to the circle at the top and the circle at the bottom. So this is not going to make a circle. This is perpendicular to the base. Let me highlight here. 1, 2, 3, 4 sides. I didn't draw it. I didn't highlight it perfectly here, but you can see this would be like the side view of a cylinder, which would make a rectangle. Problem number 4. Wait a minute. Didn't we already have a cylinder? Jumping back to number 3. Didn't we have cylinders on the first page? Oh, yeah, we did. Problem number 4. Didn't we already have cones on the first page? Oh, yeah, we did. And this is an angled slice, so it's not going to make a perfect circle. It's just going to stretch the circle, making it, you could actually name it 2 different ways. You could call it an oval, or you could call it an ellipse. Both names would be acceptable at the 7th grade level. And then problem number 5. This slice might be parallel to the triangle in the front and the triangle in the back, but it might be not perfectly parallel. Might be a little bit stretched from how it was in the front, but it's still making a triangle. A stretched triangle is still a triangle. So yes, this is going to make a triangle. Might not be the exact same triangle like you have in the front, That might be an equilateral triangle in the front. I don't know. So it might not be an equilateral triangle, but it's still going to be a triangle. Problem number 6. Now, this one was unique. If it would have went through the vertex, then a perpendicular slice would have made a triangle. Kind of like back up at the top on problem number 1 with the vertical slice of the square pyramid. But this one is going through at a different location. So we got 1, 2, 3, 4 sides. That's not a rectangle. That is a trapezoid. Problem number 7. This one is parallel to the rectangle at the bottom. So if it's parallel to a rectangle, it's gonna still make a rectangle, but a much skinnier rectangle than what you would have had here at the bottom. But nevertheless, that is still a rectangle. And problem number 8. Now this is a really interesting looking cylinder. It's kind of a fat, short cylinder. But this horizontal slice is parallel to the circle at the top and parallel to the circle at the bottom. So if it's parallel to circles, then it's going to make a circle. All right, now that we have done those problems, let's kind of spice it up a little bit here. Problem number 9, problem number 10. Can you do these problems on your own? I would like for you to try. So hit pause, try number 9, part A and B, then try number 10, part A and B, and then hit play when you're ready to see how you did. Okay, did you already do number 9, part A and B, and number 10 on your own? If you did not, you owe it to yourself to try it on your own first. Hit pause, then hit play when you're ready to see how you did. All right, part A. Name the shape resulting from a vertical cross-section and the shape resulting from a horizontal cross-section. Well, a vertical cross-section would make something like this. As you can see, this, if I would take this and look at it straight on, that would actually make a rectangle. Now, what about a horizontal slice? I would have 1, 2, 3, 4 sides. However, it is parallel to the trapezoid at the top and a trapezoid at the bottom. If you weren't sure if these were trapezoids, you should have read that this was a trapezoidal prism, meaning that the top and the bottom are trapezoids. So if my slice is parallel to the trapezoid at the top and the trapezoid at the bottom, then this should also make a trapezoid. Not a perfect rectangle. This edge here and this edge here, they're parallel, but this edge here and this edge here, not parallel. That's why this is a trapezoid, not a rectangle. All right, part B. An angled cross-section, depending on where it enters and where it exits the trapezoidal prism, would result in what shape, or maybe what different shapes? So let's try to actually do this. If I do an angled slice, and I'll admit to you, I'm not super good at drawing angled slices here. I'm trying. What would that actually make? Believe it or not, that would make a rectangle. However, if I change where that angled slice actually goes, if I angle it so that it actually kind of goes through the front, like so, then down here is longer than what it is up here, and so that's actually going to make a trapezoid. So this was meant to be challenging. In fact, I'll tell you right now, number 9 is trickier than what's going to be on the test. But if you got this right, good job for you. You can pat yourself on the back. All right, problem number 10. This one is definitely trickier than what's going to be on the test. First of all, it's a cake pan shaped like a half of a sphere. If you're like, what does that even look like? It basically looks like a bowl. A full sphere would be a ball. So you're kind of like taking a ball and cutting it in half. That would be half of a sphere. We need to name the shape from cross sections of the cake baked in this pan if they're cut horizontally and if they're cut vertically. So let's start with the horizontal. The horizontal slices would be like this, kind of parallel to the circular opening at the top of this cake pan. So if it's parallel to the circle at the top, then it's going to make a circle. Not as big of a circle as what you see at the top, but still going to be a circle nonetheless. Okay, what about vertical cuts? Okay, I almost spoiled the answer there. A vertical cut. This one's hard to draw. Okay, what is that actually going to make? If I take that slice and look at it straight on, it would make this. What is that? It's half of a circle, which has a name in geometry. It's a semicircle. Okay, and that concludes the guided notes on cross-section. Thank you for watching. We'll see you next time.